Hi, welcome to upsc Kata. In this video we are going to learn about the structure of Earth. Structure of Earth consists of 1. Crust. 2. Upper mantle. Both crust and upper mantle combine called lithosphere. 3. Inner mantle. 4. Outer core. 5. Inner core. Let's see from what the crust is made up of. It is the outermost solid part of the Earth. It is brittle in nature. The thickness of the crust varies under the oceanic and continental areas. Oceanic crust is thinner as compared to the continental crust. The mean thickness of oceanic crust is 5 km whereas that of the continental is around 30 km. The continental crust is thicker in the areas of major mountain systems. It is as much as 70 km thick in the Himalayan region. Let's see from what the mantle is made up of. The portion of the interior beyond the crust is called the mantle. The mantle extends from Moho's discontinuity to a depth of 2,900 km. The upper portion of the mantle is called asthenosphere. The word astheno means weak. It is considered to be extending up to 400 km. It is the main source of magma that finds its way to the surface during volcanic eruptions. The crust and the uppermost part of the mantle are called lithosphere. Its thickness ranges from 10 to 200 km. The lower mantle extends beyond the asthenosphere. It is in solid state. Let's see from what the core is made up of. As indicated earlier, the earthquake wave velocities helped in understanding the existence of the core of the Earth. The core mantle boundary is located at the depth of 2,900 km. The outer core is in liquid state while the inner core is in solid state. The core is made up of very heavy material mostly constituted by nickel and iron. It is sometimes referred to as the NIF layer. Sources of information about the interior. So let's see different types of the sources from which we get the information about the interior of the Earth. There are two types of sources: 1, direct source, and 2, indirect source. Gold mines in South Africa, and volcanic eruption, are the example of direct sources. Earthquake and earthquake waves, are the example of indirect sources. Let's see in detail about direct sources. The most easily available solid earth material is surface rock or the rocks we get from mining areas. Gold mines in South Africa are as deep as 3 to 4 km. Going beyond this depth is not possible as it is very hot at this depth. Besides mining, scientists have taken up a number of projects to penetrate deeper depths to explore the conditions in the crustal portions. Scientists world over are working on two major projects such as Deep Ocean Drilling Project and Integrated Ocean Drilling Project. The deepest drill at Kola, in Arctic Ocean, has so far reached a depth of 12 km. This and many deep drilling projects have provided large volume of information through the analysis of materials collected at different depths. Volcanic eruption forms another source of obtaining direct information. As in when the molten material, magma, is thrown onto the surface of the Earth, during volcanic eruption it becomes available for laboratory analysis. However, it is difficult to ascertain the depth of the source of such magma. Let's talk about the indirect sources. Earthquake. The study of seismic waves provides a complete picture of the layered interior. An earthquake in simple words is shaking of the Earth. It is a natural event. It is caused due to release of energy, which generates waves that travel in all directions. Let's see, why does the Earth shake? The release of energy occurs along a fault. A fault is a sharp break in the crustal rocks. Rocks along a fault tend to move in opposite directions. As the overlying rock strata press them, the friction locks them together. However, their tendency to move apart at some point of time overcomes the friction. As a result, the blocks get deformed and eventually, they slide past one another abruptly. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called the focus of an earthquake, alternatively, it is called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface, nearest to the focus, is called epicenter. It is the first one to experience the waves. It is a point directly above the focus. Earthquake waves. All natural earthquakes take place in the lithosphere. You will learn about different layers of the Earth later in this chapter. It is sufficient to note here that the lithosphere refers to the portion of depth up to 200 km from the surface of the Earth. Types of earthquake waves? There are two types of body waves. They are called P and S waves. P waves move faster and are the first to arrive at the surface. These are also called primary waves. The P waves are similar to sound waves. They travel through gaseous, liquid, and solid materials. S waves arrive at the surface with some time lag. These are called secondary waves. An important fact about S waves is that they can travel only through solid materials. This characteristic of the S waves is quite important. It has helped scientists to understand the structure of the interior of the Earth. Reflection causes waves to rebound, whereas refraction makes waves move in different directions. The variations in the direction of waves are inferred with the help of their record on seismograph. The surface waves are the last to report on seismograph. These waves are more destructive. They cause displacement of rocks, and hence, the collapse of structures occurs. Propagation of earthquake waves. Different types of earthquake waves travel in different manners. As they move or propagate, they cause vibration in the body of the rocks through which they pass. P waves vibrate parallel to the direction of the wave. This exerts pressure on the material in the direction of the propagation. As a result, it creates density differences in the material, leading to stretching and squeezing of the material. Other three waves vibrate perpendicular to the direction of propagation. The direction of vibrations of S waves is perpendicular to the wave direction in the vertical plane. Hence, they create troughs and crests in the material through which they pass. Surface waves are considered to be the most damaging waves. Emergence of shadow zone. Earthquake waves get recorded in seismographs located at far-off locations. However, there exist some specific areas where the waves are not reported. Such a zone is called the shadow zone. The study of different events reveals that for each earthquake, there exists an altogether different shadow zone. Figure 3.2, A, and B, show the shadow zones of P and S waves. It was observed that seismographs located at any distance within 105 degrees from the epicenter, recorded the arrival of both P and S waves. However, the seismographs located beyond 145 degrees from epicenter, record the arrival of P waves, but not that of S waves. Thus, a zone between 105 degrees and 145 degrees from epicenter was identified as the shadow zone for both the types of waves. The entire zone beyond 105 degrees does not receive S waves. The shadow zone of S wave is much larger than that of the P waves. The shadow zone of P waves appears as a band around the Earth between 105 degrees and 145 degrees away from the epicenter. The shadow zone of S waves is not only larger in extent, but it is also a little over 40% of the Earth's surface. You can draw the shadow zone for any earthquake provided you know the location of the epicenter. Let's look at the summary of the lecture. What we have studied in the lecture is the structure of the Earth, which consists of crust, upper mantle, lower mantle, inner core and outer core. The crust and upper mantle made the lithosphere. And also different types of the sources from which we get the information about the interior of the Earth. There are two types of sources: one, direct source, and second, indirect source. Gold mines in South Africa, and volcanic eruption, are the example of direct sources. Earthquake and earthquake waves are the example of indirect sources.